Okay, on the quiz. It's going to ask the following question. Is it linear or exponential? And write an equation. Okay, so is it linear or exponential, and you need to write an equation. Okay? Everybody with me?
Get a piece of paper out and write these down.
Now, how am I going to tell if it's linear or exponential? First of all, do you really care about the x's all that much? When you write the equation, you do, but when you do this, you don't. Okay? When you're just looking to see whether it's exponential or not. When you write the equation, you're going to want to know the zero value on these. You with me on that? So you're going to want to know the zero value on these when you write the equation. But besides that, you really don't care about the x's. All you care about is the y's. Okay? How do I know if it's exponential or if it's linear looking at the y's? You guys tell me. Stetson, what do you think? Is this one linear or exponential? Is this one linear or exponential? And why do you think that?
Don't they? Isn't the bottom one linear?
Yes. How come?
Because aren't you adding
You're adding what every time?
4?
4. Now here's how you can check that. All you need to do is say, hey, take the second and then subtract the first, and you will see. So if you think about this, this is what should go in your notes. Second, subtract first is how you tell if it's linear. So if I go -1 minus -5, second, subtract first, I get what? 4. Everybody agree with that? Now do the same thing with the third and the second. So I'm going to take 3 minus -1. What does that give you? If those are the same, you can pretty much tell that, hey, it's going to follow that pattern. You can kind of say, am I adding 4 every time? Yes. So this is a linear equation for sure. So I'm going to write that outside here. Linear equation. And then I say, all right, I know it's linear. How do I write an equation? This 4 has something to do with the equation. The other part that has something to do with the equation is that starting point. That's all you need. This is the common difference. So linear equation is y equals what? mx plus b. This common difference, m, is 4. Okay? So the slope, if you will, is always this common difference. Okay? The slope is the common difference. The y-intercept, the b part, is where it is at 0. So this equation is very simple. It's y equals, what's the common difference? It's common difference, say it out loud. 4, good. X, and then what is the y-intercept? Where does it cross the y-axis at, where x is 0? It's what? -1. Yeah. Very simple. Okay? So if it's linear, that's not very hard. That's what it's going to look like. Okay. Top one. Is it linear? No, you can tell it's not if you take second minus first, 1 minus a third, and then you take 3 minus 1. 3 minus 1 is 2. 1 minus a third is 2/3. Are they the same? No. So it's not what? What do we know it's not? It's not linear. Okay? How can I check for exponential? Well, notice we subtracted to check for linear. What's the opposite of subtract? Well, you would think you could either add, or you can think the same thing with division and multiplication is subtraction and addition. If I'm subtracting to see if it's adding a value, I should divide to see if it's multiplying a value. So that's what I'm going to check. I'm going to do this one with division. So I'm going to divide. So I want to divide the second, and this is what needs to go in your notes, divided by the first. Okay? And if those end up the same as the third, divided by the second, if these are equal, then you're probably going to have, well, you do. You have a situation where we have an exponential function. This will be exponential.
Isn't it just timesing by 3 every time?
It is. Now, some of you can just see it. So Stetson can just see, hey, I'm timesing by 3 every time. I'm saying, let's say you don't know. You're not sure, right? You're not really good at times tables. You're not sure about it. That's fine. Just check the second divided, and you can do it on a calculator. You can go 1 divided by 1/3. If you do it on a calculator, use a parenthesis there. And you can do that, and it'll tell you, all I'm going to do is flip and times that. It's going to be 3. If I take the third divided by the second, that's 3 divided by 1. That also is what? 3. That's my common what? Difference. Everybody got it? Or sorry, common multiple. It's what I'm multiplying by each time. That's exactly what Stetson said. If you notice, I'm multiplying by 3 each time. What's 1 times 3? 3. What's 3 times 3? 9. What's 9 times 3? 27. What's a third times 3? 1. Yeah, so every one of those are just timesing by 3. So this is going to be part of my equation. And again, the 0 value is going to be part of your equation. Here's the equation. You want to put this in your notes, just like you have y equals mx plus b for linear. For exponential, we have, let's see here. We're going to go a times b raised to the x. Okay, equals y, sorry. That's going to be my exponential. The a value is the starting value. So this value, this is kind of a weird one, is right there. So this one's kind of weird because they're the same value. So it's y equals 3, but that 3 came from the starting point. Are you with me? So the a value is the starting point. The base value is what you're multiplying by every time. What am I multiplying by every time? Also 3 raised to the x. That's my answer. Okay. Are they always going to be both the same? No, very rarely. In fact, that's surprising that 0 ended. I should have moved it over so that it wasn't, but it's wherever the 0 value is your starting value, a, and your common multiple, the thing you're multiplying by every time, is your base value, b. Everybody got it? Could that be a fraction, by the way, for the base value? Yeah, instead of timesing by 3, I could have been timesing by 1/3 and went the opposite way. I could have started with 27 and ended with 1/3, and it would have been the same. Okay, only it would have been 1/3 for my base. Okay, so just pay attention to that kind of stuff. Okay, here we go. Number 2. Okay, number 2. Here we go. Everybody do this with me. And right, hey, this is number 1. Okay, depending on which test you get, it'll be one of those 2 types, right? Okay, here's number 2. Okay, number 2 is and 3. So sorry, this is 2 and 3. I'm only going to do one of them, but this is 2 and 3. It's going to give you an equation, y, or sometimes I'll write it the way they write it, because it make it sometimes harder for some people. Y or f of x doesn't matter. It's the same. Okay, that's saying find the y value. So f of x is how they write it, equals -2 parenthesis 3 to the x when x equals 2. Okay? Can you find that? What's that even asking? What do you think, Liberty? What do you think this is asking me to do? What is it telling me that x is? So what does it want me to plug in for x right there? 2. That's all it's doing. So questions 2 and 3, it's wanting you to substitute the value they give you for x into that exponent. That's all they want you to do. Can you do this on a calculator?
Yes.
Exactly the way it's written. Okay, you can literally punch in -2 parenthesis 3 close parenthesis. Make sure you use what on the quiz if you're using your calculator. Parentheses. Parenthesis, close parenthesis, hit the raised to the, that's the caret key, 2. Some kids just put a 2 on the outside. They forget to hit that caret key, and then it won't raise it to an exponent, it'll times it by 2. I don't want to times it by 2, I want to raise it to the second power. You got it? Okay, now really this means 3 raised second power, 3 squared is 9. 9 times, because you do exponents before you do multiplication, 9 times -2 is -18. That's my answer. Okay, now again, you can just punch that into a calculator, it'll work, but you got to use the parentheses correctly on the calculator. You got to use the exponent key correctly on the calculator. Make sure you're comfortable with doing that on the calculator. Okay? But that's all these are. So 2 and 3, you're just going to what? Substitute. That's it. All it is substitution problem. Got it? Got it, Wyatt?
Yeah.
Okay. Here we go. Number 3, or 4, sorry. Number 4, okay? And 5. 4 and 5. I'm going to give you a couple different ones here. I'm going to give you a choice here. So let's say I have y equals 3 times 0.8 raised to the, or let's even go like this. Let's go 4/5. 4/5, which is the same thing, but 4/5 raised to the x, and y equals 1/2, 1.035 raised to the x, okay? This one just says, tell me if it's exponential or, tell me if it's exponential growth or exponential decay. Is it growth or decay? Okay, it's going to have questions like that. Is it growth or decay? And then the second thing it's going to ask you is, by what percentage is it growing or decaying? Or what is the rate of growth or decay? Okay. All right. So what equation are we using? And we use this equation a ton for growth and decay. What is it? A sub t equals what? We've done it a million times already. You guys tell me what it should go next. What is it? Go ahead, Stetson. You guys remember? What goes right here? It's the starting amount. What do we use for a variable? P. Go ahead. Good. Nice job, you sir. P, and then what?
Rate.
Oh, it's got something before the rate though.
M.
You guys remember?
It's 1.
1. Very good, because you got to have 100% plus the rate as a decimal, or minus if it's what? Decay. So minus is decay, plus is growth. This should already be in your notes, but make sure it is. And then we're going to have it raised to some amount of time t. Okay? This is very similar to these. Okay? All I'm checking is this inside here. If this inside is greater than 1, we have growth. If the inside is less than 1, we have decay. Okay, that's the first step. So, everybody look at these two. I'm going to call on you. Be ready. Okay, Braden, is this one growth or decay? What should you be looking at?
Growth.
It's not growth. Okay. You're looking at the first number. Don't look at the first number. That isn't telling you whether it's growth or decay. Remember, it's growth if it's greater than 1, but he's looking right here. Do not look at this number. This is not the one I'm looking at. I'm looking at that one. Is that number, 4/5, greater than 1?
No.
No. So therefore, we must have what? Decay. So don't look at the number in front. Look at the number in the parenthesis. Everybody got it? So this one is decay. Okay, Zach. Is this one growth or decay? How do you know? The number in the parenthesis is what? Bigger than 1, okay? And that's all I'm looking at. So this is pretty easy, but look at the number on the inside of the parenthesis. Don't look at the number on the what? Outside. That'll throw you off, okay? Look at the number on the inside. Is it bigger than 1? If it's bigger than 1, growth. If it's less than 1, decay. Pretty easy, okay? Now, to find out the rate of growth or decay, I have to kind of do the opposite. So here it's pretty easy. I'm going to subtract 1 if it's growth. Okay, if it's growth, I'm going to subtract 1 from it. Okay, actually I'm going to, well, kind of, sort of. Okay, so I'm going to go 1, and then I'm going to go this minus 1. What do I get? 0.0 what? 35. Change that to a what? What do I need to show it as? The rate is saying I need that as a percentage. So I don't want to leave it as 0.035. I want to change it to what, Sadie? How do I change that to a percentage?
I don't know.
How do I change a decimal to a percent?
Don't you move the decimal?
Move the decimal how many places?
2.
Is it 1 or 2? 2. Move it 2 places back, and I end up with 3.5 what? Percent. That's all I got to do. Okay? So when it asks for rate, it wants a percent. That's my answer there, 3.5%. Okay, now when it's doing decay, it's a little bit different. See how I subtracted 1 from this? That was easy because I just took off the 1, right? That's easy. But here, I've got to take 1 minus, so instead of -1, it's 1 minus whatever this value is, the b value, okay? So this is 1 minus 4/5. Okay? Got to have a common denominator, 5/5. 5 minus 4 is 1/5. That is my what? Rate. But it says a fraction. I need it as a what? Percent. So I got to do that on a calculator. Do 1 divided by 5. Tell me what it is. Brendan, do that for me, will you please? 1 divided by 5. What is it as a decimal? 0.2. Now, what is it as a percent? Liberty, what's that going to be as a percent if I have 0.2? What is it as a percent? Again, you just want to move it how many places? 2 places. So it's going to be what? 20%. If there's nothing there, you have to put a 0 to hold the place. So this is a 20% decay. This is 3.5% growth. Okay? So know whether it's decay or growth. That's easy. Just look at that. And then from there, you're going to say, all right, I know it's decay or I know it's growth. How do I do it? If I subtract 1, if it's growth, from the base value, from the b, so this is b minus 1, I'm going to get my growth rate. If I take 1 minus b, a little bit opposite there, I'm going to get my decay rate. Okay, that's the only things you need to have. So I'd have those in my notes. B minus 1 for growth, 1 minus b for decay. I'd have that in my notes. B minus 1 will give you the growth rate. 1 minus b will give you the decay rate. Everybody got it? Okay, here we go. That was number, what number? I forgot. 2.
No, that was 4 and 5.
4 and 5, sorry. This is number 4 and number 5. Okay, here we go. Number 6. I'm going to do this one just alone because it's easy. So here we go. We're going to have, I don't know, something, doesn't matter, raised to the 3x plus 7 equals, again, doesn't matter, raised to the 5x minus 3. Okay? Doesn't matter what the base is. Think those stars matter? Doesn't matter. As long as they're exactly what? The same. That's all you care about. Okay? As long as the bases are the same, doesn't matter whether they're stars, 3s, 5s, -2s, nobody cares. If these bases are exactly what? The same, what can you do with them? Drop the bases, and then just write your equation. 3x plus 7 equals 5x minus 3. So Keena, what do I want to do to both sides to get all my x's on one side? So notice I said focus on the what first? X. Focus on the x's first. What should I subtract from both sides? 5x, she says. Is that okay? Sure, it might make it negative, but that's okay. She's bringing her x's over here. Negative 2x plus 7 equals negative 3. Once you've brought all the x's to one side, get the x by itself. So Devin, if I want to get this x by itself, what do I got to get rid of first? The negative 2 or the 7?
Negative 2.
No, that's the mistake most kids make. We don't want to get rid of the multiplication until the very end. We want to get rid of addition or subtraction. So I want to get rid of the plus 7. I've got to what? Subtract 7. Good. Okay. Negative 2x equals negative 10. Dom, what will I do next? How do I get that x by itself? What's the negative 2 doing to the x? It's timesing, so I've got to do the opposite, which is? Divide. Good. I'm going to divide by negative 2. What's the negative divided by a negative? Positive. What's 10 divided by 2? 5. That's my answer. Okay? That's number 6. Number 7. Pretty similar, but not quite. Let's say I have 3 to the x plus 1 equals 81. Okay? This is number 7. Yep, this is number 7. So number 7 looks like this. What's the problem with this one compared to this one? Number 6 compared to number 7. What's the difference?
Bases are
The bases are the same here, and the bases what? Aren't the same here. What do I do when the bases aren't the same? Something you might want to write in your notes. What's the first step when the bases aren't the same?
Yeah, I break it down.
Factor tree it down, right? I want to factor tree it down. So this will be using a calculator. What's the first thing you want to try?
Well,
Try the same base, right?
Yeah.
If this base is 3, what should I try to put into 81? 3. I know 9 goes into it, but I don't want to break it down into 9s. I want to break it down into what? 3s, because I got to have the same base. Everybody with me on that? So I'm going to go 3 into 81 how many times? 27. 3 into 27. 9. 3 into 9. 3. And then count the leaves. Remember on the tree? Don't count the branches. Don't count the 27 and the 9 and the 81. Count the leaves, the ones at the very end. So that we have all these 3s. How many 3s do I have? Let's see, who haven't I called on yet? Kate, how many 3s do I have?
4.
4. So I'm going to write, this side doesn't change. 3 to the x plus 1 equals 3 to the what? 4. Okay? Wyatt, what can I do now here? Are the bases the same?
Yeah.
So what can I do with them? What did I do with them here?
Drop.
I drop the bases. Yep, I can just drop them. They're gone. X plus 1 equals what? 4. Those exponents have to be the same if the bases are the same. What do I do to both sides, Wyatt? Get the x by itself. How do I get the x by itself, Wyatt? X plus 1 equals 4. How do I get the x by itself?
-1.
Minus 1, good. And x equals 3. That's my answer. I'm done. Okay? So that is all the way through 7. Okay, remember there's only 12, so this isn't got a ton more. Okay? So that's through 7. Here's number 8. I'm going to switch this back. Put this over here. Okay. Oh, I should have just left that, but that's okay. Write it. Wait, that's wrong. Okay, something like this. Let's say plot the points and tell me whether it looks linear, exponential, or neither. Plot the points and tell me if it appears linear, exponential, or neither. This is a lot like Alex assignments, right? Where you just plot the points and see how it graphs. Okay. So I just got to plot them on a XY axis. Remember, this is your X, this is your Y, and then every one of these points, the first value is the what? X or the Y? X, and the second value is the Y. So where should I go to graph 2, 8? Put your phone away. Y, put your phone away. Okay, where's my X value? 2, and what's my Y value?
8.
So I'm going to go over what? 2. Always go over right or left first. Go over 2, up
8.
4, 5, 6, 7, 8. Brendan, where will I go next? 2, 8. What's the next one?
-2.
-2 on the X, so I go left 2 and up what?
1/2.
Just a half, not very high. Okay, 0 what? Liberty, 2, 0, 2. And 1 what? Devin?
4.
4, good. 1 to the right, 4 up. Okay? Now look at these points. Do they look like they're going to form a line or a curve? Yeah, you can see, especially this point kind of gives it away. These almost look like a line, don't they? But this point added is telling you, you know what, that's not a line, that's a what? That's a curve. It's curving up. Okay, so look at all the points together and say, hey, does it look like a line or a curve? This is really a curve. This is a what then? If it curves like that, what is that curve looking like? What do we call it? Exponential. This is an exponential curve. Okay? Sometimes it's kind of hard to tell unless you take into account all the points. Don't just think, oh, I can graph a couple points and see what it looks like. Because then it might look like a line. It only takes 2 points to make a line. Any 2 points will make a line. They'll all look linear. You know what I mean? But when you include all 4 points, now all of a sudden it could be a line, could be exponential, could be neither. If they're just kind of scattered everywhere, and there's no, you can't really connect them in a nice smooth curve up or down, then it's not exponential either. It's just simply nothing, right? Neither. Okay? So, but it's probably going to be exponential or what? Linear. Linear, you'll be able to see it creates a line, but here we have exponential. This is number what? 8. Everybody got it? Okay, number 9, another graphing one. Okay, so number 9 looks like this. F of x equals, and then let's say it is 2 times 1/2 x. Okay, how would this graph? Well, if it asked me to graph this on a graph, don't start with the graph. What should you make? What did you make when we were doing it on Alex?
T-chart.
I made you do it on a piece of paper. What did I make you put?
Oh, a table.
A little table, T-chart, right? So I'm going to make me a table T-chart right here. I'm going to plug in some x's and find some y's. What are some smart numbers to do? Because they're just not very big. They'll make it not very big. Start at 1 and -1. Start at 0. And then maybe we'll do a 2 and maybe we'll do a 3, or maybe we'll do a 2 and a -2. We'll see where we go. But we're going to at least do those 4. Okay? So I'm plugging in 1 for x. Okay? So think about this. I'm plugging in 1 for x. Zach, if I plug in a 1 for x, what's 1/2 raised to the first? What's anything raised to the first? The base. So I'm plugging in 1 for x there. I have a 1/2 times 2. What's a 1/2 times 2, Zach?
1.
1. So at 1, I'm going to be at what? 1. Everybody agree with that? Okay? Now, here's the tricky one. Let's do a -1. This one's tricky. When I plug in a -1 there, what does it do to that fraction? Does it make it negative? Does a negative exponent make anything negative? No. Write that in your notes, by the way. I don't want you messing that up on the test. A negative exponent doesn't make anything negative. It reciprocates it. It flips it. You can either put flip or reciprocates it. So instead of a 1/2, what will it become? What's the reciprocal of a 1/2? 2 over 1, right? Times 2. What's 2 times 2? 2 times 2 is what?
4.
4. Okay? What's anything raised to the 0? What's a 1/2 raised to the 0? What's anything raised to the 0? You want to write this in your notes.
1.
Bryson, write this in your notes. Anything raised to the 0 is actually 1. Write that in your notes. Anything raised to the 0 is 1. So this being raised to the 0 makes that part 1, but I still have to times it by the 2. What's 1 times 2? 2. Okay. Let's go 2. What's going to happen at 2? Well, if I think about this, I've got 2 times a 1/2 raised to the 2nd. Squaring that, squaring 1 is 1. What's 2 squared? What's 2 times 2?
4.
4. That's going to stay in the denominator, though. What's 2 times a 4? You can do that on a calculator if you want, and then make sure you use your fraction key, but it's going to be a 1/2. So this is a 1/2. So it will be nice to go in a negative direction, because that's going to give me a bigger number, not fractions. If you keep going in a positive direction, you're going to get more fractions, right? So let's go on a negative direction. Let's put in -2 for x. So I've got 2 to the 1/2 times -2. What's that negative going to do with this fraction? Flip it, and now I'm going to have 2 to the second. What's 2 squared? What's 2 times itself? 4. So this is going to be 2 times 4. What's 2 times 4? 8. How many points do I have? I have 5. When you have 5 points, you're going to have a pretty good look at the graph, okay? Now go ahead and graph it. Okay? Where's this point at? Brendan, where should I go? Right one, and I want you to tell that to me that way, okay? X and then Y. Right one, up one. Okay, good. Okay, Zach, where should I go on this one? Left one, up 4. Left one, up 4. Okay, there's that one. Braden, where does this one go?
Up 2.
Just up 2. I don't go right or left, I go straight up 2. Good job. That was a hard one. Good job, Braden. Okay, and then where do I go on this one? You see here?
Right 2.
Right 2,
Up
but only up 1/2. Okay? Where should I go on this one, Devin?
2 up 1.
Right or left? Left 2, up how many?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Again, you can definitely see this as a what? Exponential curve. Okay? This is still exponential. Is this growth or decay, by the way? It doesn't ask this, but you should be able to tell. If it's going down, it's what? Decaying quickly. If it's going up, it's what? Growing quickly. I mean, that's growth or decay. But it doesn't ask that. It just says graph the function. Okay? So if it says graph the function, what should be your first step? Make a what? T-chart. Write that in your notes. If I'm asked to graph a function, make a T-chart. Okay? If I'm asked to graph a function, make a T-chart. You're going to want 4 to 5 points minimum. Okay? Otherwise, you won't be able to see the pattern. So go 4 to 5 points, make a T-chart. Okay? That's number what? 9. Okay, number 10. A little bit tougher. Story problem. Okay? Day 0, this many people were infected, so we'll just go COVID, because hey, everybody's got the COVID now, so call it with COVID. Day 0, okay? There are 2 people infected with COVID. Day 1, all of a sudden there are 8 people infected. Day 2, there are
32.
32. There we go. And day 3, 128, I think. Okay? So it's going to give you something like this. Okay? And then it says this. Here's the questions. So it's going to say, hey, this is the days. Here's the COVID cases that we saw in a certain area after day 1, after day 2, so forth. How fast is this growing? And it's going to say this. Write an exponential function. Okay, write an exponential function for what's happening. Okay, how do I do that? How do I write an exponential function? This is a lot like the first one, the very first question, same type. Okay, how do I write a function? Well, first of all, do you think it's exponential or do you think it's linear?
It's definitely
It's definitely exponential, right? It's getting so big so quick that there's no way it's linear. So let's check the exponential. How do I check the exponential? Take the second, again, this is in your notes, but make sure you have it, divided by the first and see if it equals the what? Third divided by the second, and you can keep going. This should equal the fourth divided by third.
Isn't just
And you can keep seeing what's happening. So if I do 8 divided by 2, what is that?
4.
4. And then if I do 32 divided by 8, what will I get? 4. So the common difference is what? 4. What's the 0 point? What's the starting point? How many were there on day 0, on the very first day that we even saw it?
2.
There was 2. So it's 2. 4 is the base value. raised to the what? Raised to the x, or t for, or d for days, or however you want to say that. I'll go t for time, equals the amount over time, right? So after 1 day, how many were there? If this would have been ace of 1, would have been 8. Ace of 2 would have been what? 32. Ace of 3 would have been how many? 128, right? It'll keep going. Okay, so let's say this is the outbreak. Now, let's say that we are going to declare a pandemic. So we're going to say there's a pandemic if we end up with 500,000 cases. Okay? We're going to declare it that we have a pandemic if there's 500,000 cases. Okay? If we go 11 days, will we declare a pandemic? That's going to be the question. We will declare it a pandemic if we have 500,000 cases. In 11 days, ace of 11, will we declare a pandemic or not? I really don't even know the answer right now. But I know how to find it. How do I find it? Put in what for t? 11. Just see if in 11 days we're going to have 500,000 cases. 2 times 4 to the what? 11. That's all I got to do. Can you do it on your calculator just like that?
Yeah.
Yeah, just use a parenthesis, use your exponent. What does it say?
8388608.
Wait, I should have said this was 5 million cases. That would have been closer to truth, I guess. I didn't know what I was doing there. But for sure, would I declare a pandemic after 11 days?
Oh, yeah.
Oh, yeah, I would declare a pandemic after 11 days. Okay? So, yes, I could definitely declare a pandemic. That's it. Okay? So, the first question is going to be write an equation. Second one's going to give you a value, probably like 5 million cases, something like that. And then say, will I declare a pandemic after this many days or not? Will I declare a pandemic after 11 days? Yes. That's how fast it's growing. Now, that might not be true necessarily for COVID, but it's an example. Okay? So that's how it works. Okay, let's look at 11. Okay. Here we go. YouTube channel. Okay? You guys ever heard of YouTubers?
Yeah.
Oh,
What do they do?
Make videos.
Make videos and then what?
and then make tons and tons of money.
They make money off their video. How in the heck do they make money off their videos?
Viewers, subscribers.
Viewers, subscribers, and then advertisers, right? Because if you have a lot of subscribers and a lot of viewers, then advertisers will pay you to throw in ads at the beginning and the end, and sometimes even in the middle of your videos, and you'll make tons of money, right? Okay, so I'm a golfer, you guys know that, and I follow Good Golf on YouTube. Any of you guys follow Good Golf on YouTube? Oh, you do, Cage? All right, so Cage is a golfer too, aren't you? Yeah. So if you follow Good, they're a bunch of good guys and they golf, and it's kind of a fun little thing. They're just golfing, really, but they're pretty good golfers, and it's just interesting. And the way they get along and the banter they have, it's just funny and it's cool. So they have a lot of followers. Okay, so this is what happens. So let's say we're following Good. Okay, Good starts their channel in 2016. Now, I don't think they actually started then. I think it was like 2018. But let's say they started in 2016. And then when they first start the channel, they have 10,000 followers. Okay? All right. Let's say that every year they are growing by 22%. Okay? Their followers grow by 22% every year. Okay? So grow by 22% every year. Okay? So they start out with 10,000 followers in 2016. They're going to grow by that every year. How many people will be following in 2020? That's the question. So question A. Oh, wait. Question A. Sorry, my bad. Question A. Write an equation. Question B, how many followers or subscribers, I should say, subscribers in 2020? Okay, how many subscribers would they have in 2020? Okay, what's the equation going to be? Is it growth or decay?
It's growing.
It's growing. By the way, I have a YouTube channel. I have some YouTube videos on there. And guess what? My channel is decaying. I had like 35, 40 followers when we were in the start of the pandemic because all the kids were watching videos. This was 2 years ago. Now, I don't have any followers hardly. Shocking, really. I don't know who doesn't want to watch a nice math video, but it's the way it is. My followers are, I'm decaying, right? Just like my body. It's a horrible thing. All right, so we're going to write an equation for this of followers. So what does this represent? Remember, we're using the same, we're using the same equation. We're using a sub t equals p1 plus, because it's growth rate raised to the t. That's all we're doing. We're using the same equation. So what equation am I going to write? A sub t, the final amount, will be the starting amount, 10,000 followers or subscribers, and then we're going to have what? 1 plus what? Don't go 22. I see some kids write 23 in here. Don't go 1 plus 22. Go 1 plus what? How do I change that percent? To a decimal, right? So it's point what? 22. So don't forget to change it to a decimal. So it's 1.22 raised to the t. Okay. Now I'm ready to go. I want to know how many subscribers they're going to have in what?
2020.
How many years is that? Now don't put in 20 years. Again, big mistake. I have kids try and put in 20 for the years. It's not 20 years. When did they start the channel?
2016.
Now it's 2020. How many years have passed? 4. So I want to find a sub what? 4. Does everybody see how we got 4? You can do it on a calculator. Just go 2020 minus 2016. That's how we got the 4. So now I just plug in 4t. Okay? I just plug in 4 for t. I just plug it into my calculator. What'd you get?
22,000.
Just tell me the numbers.
2,
Okay?
2, 1, 5, 3.3456.
Okay, and I don't care about the points because we're just talking followers. Those are people who are thinking about subscribing, right? so we're just gonna go like this. How many is that then? It's really 22 what? 1,153 followers. Okay, about. Again, we could be off a little bit, but we're pretty close. So the amount of followers they'll have, or the amount of subscribers they'll have, will be 22,153 subscribers in 2020 if they grow at that rate. Now, by the way, they've grown at probably 3 times that rate. They've been going really fast. There's a lot of subscribers to their channel. And so it's kind of more of an exponential growth. Now, will that exponential growth continue though? No, that's the funny part about subscribers, all that sort of stuff. It goes up like this, really good exponentially, and then all of a sudden it starts to what? Level off and slow down, and the growth rate becomes less. There's just no way. You're going to only reach a certain number of golf fans, right? There's not millions and millions of golf fans. You're only going to get which golf fans are actually watching YouTube, which isn't a ton. So you won't have that happen all the time. Okay, number 12. So that was number 11. This is the last question. Okay, last question. I should have left that equation on there, but that's okay. I can slide this over. Let me just slide this. I'll do that. Let's slide this over. Because we have the equation right there. Because it's going to be the same equation used for number 12. Okay? Number 12, we're buying a truck. Everybody got it? So we're going to buy a brand new truck. Okay? Brand new truck. It's valued at $60,000. Now again, on the test, will these be the same? Will we be buying a brand new truck on the test? Yes. Okay? It's the same type of question. That's what I mean by if you're taking good notes, the question is the same. Only thing that's changing is the what? The numbers. It won't be $60,000 truck. You know, it'll be a $45,000 truck. It'll be a $75,000 truck. Whatever, right? But I'm going to throw some value of a truck. For this one, we're saying it's $60,000 truck. So this is the truck, new. New truck. There's what it's worth. Okay? After 5 years, we're going to say the value of the truck is $32,000. Okay? Okay? In 5 years, the value of the truck is going to be $32,000. Okay? So it's worth $60,000 now. It's going to depreciate over time. Truck's going to be worth $32,000 in 5 years when I go to try and sell it back and maybe get a different one. It's going to be worth $32,000. Okay? Here's the questions. Write an equation to figure out the depreciation rate. Write an equation to figure out the depreciation rate. That's what it's going to ask for. Write an equation to figure out the depreciation rate. And then tell us the depreciation rate. Okay? That's question A. Question B, what's the truck worth in 10 years? Okay? Question B, what's the truck worth in 10 years? Okay? So find the depreciation rate and then tell me what the truck's worth in 10 years. What equation am I using? Same thing, only instead of a plus, what am I going to use?
Minus.
I'm going to use a minus, okay? So, let's start off with that. So I want to find that rate. Do I know what it's worth in 5 years? Do I know ace of 5? What's it worth in 5 years? 32,000. This is 32,000. Okay? Do I know what it's originally worth? 60,000. Do I know the rate? No, that's what I'm what? Finding. Yeah, it says find the rate. So I'm going to go 1 minus what? R. I know I'm using a minus though because it's what? Depreciating or going down in value. Okay? So I'm going 1 minus R raised to the t. What's the t? Remember, this is 1 minus R raised to the 5 because 5 is the what? T. Everybody got that? Write that equation down because this is a little trickier than some of the others. Because I'm finding rate. It's easier when I just plug in the rate, right? But here I have to find the rate. So watch how I do this. A lot of kids, I'll show you the mistake that's going to be made on the test. You guys will make this mistake. A lot of kids want to take this 60,000 and try and distribute it. Big mistake. Huge. Beautiful mistake. Biggest mistake ever made. Don't do it. Wrong. Okay, what do I want to do? Divide both sides by what? 60,000. Yeah, I want to divide by 60,000. Don't times it, divide it. This will give you a decimal. Okay, do this on your calculator for me, Braden. Or Brendan, sorry, Brendan, will you do this on your calculator for me? 32,000 divided by 60,000. 32,000 divided by 60,000. What'd you get? It's going to be a decimal. You could even just do 32 divided by 60.
0.5333.
0.5333. Okay, repeating. Everybody got that? That makes sense. It's a little over 50%. That's fine. Okay? All right. I have 1 minus R to the 5th. Keep your calculator out. Because I'm going to have to do what to get that by itself? Got to get rid of the 5th. This is the tricky part. Okay? I've got to take, if I have x squared, how do I get rid of the squared? I take the square what? Root. Well, if I have x to the 5th, I've got to take the 5th root. Now, on your calculator, there's an x root key. Look on your calculator. I'm going to look with you because I want you to know where it is. It is second exponent. But before I hit that, I've got to hit 5. So everybody hit 5. Okay, hit 5. Then hit second exponent, so second caret key. That's going to be x root. So it should actually say the 5th root now, but it's the x root key on your calculator. And then 0.5333. Do that on your calculator. Okay, so on the calculator, you're going to hit 5 first, right? Then I hit second caret key, that's second x root. There you go. See how it says x root? And then 0.5333 and hit equals. And we end up with what? 0.88. We're just gonna call it good enough right there. We're gonna go 0.88, okay? And then we're gonna have 1 minus r, okay? Now, that's what got rid of the fifth root. Brendan, do not. Braden,
first.
put those away. No, just hand them to me. God, you guys need to quit thinking. Piss me off. Okay, you see it. What am I going to do next to get that r by itself? Subtract 1. Okay, what's 0.88 minus 1? Do it, Brady. Or Brendan. What'd you get? 0.88 minus 1.
Negative 0.12.
Negative 0.12 equals negative r. How do I get rid of the negative? Divide by negative 1. So just divide by negative 1. R is what? 0.12. That truck is going down by what? 12% every what? Every year. Okay, that's what it's going down every year. That's my rate. Okay, now I got to do 1 minus the rate when I plug it in to find this 10. So now I'm doing the 10. So what is the rate? 12 what? Percent. That's the answer to A. Okay, now let's do this. A sub 10. Okay, A sub 10 right there. Okay, what? I'm going to start with what? What's the starting amount of the truck? What? 60,000. I'm going to put in parentheses 1 minus the rate. So 1 minus 0.12 is what? You can do it on a calculator if you need to. What's 1 minus 0.12, Keena? What's 1 minus 0.12?
0.88.
So 0.88 raised to the, how many years? 10. Liberty, will you do this for us? Do 60,000 parenthesis, 0.88, close parenthesis, raised to the 10. This is the value of the truck after 10 years. So the value it's going to be, how much it's worth after 10 years, is going to be what? Go ahead, Liberty.
167.005.
Okay, so 1671.
Yeah, 0.0.
Yeah, I don't care about the 0.0 part. So it's going to be worth about what? $1,067 or $671. Is that right? 1671. So it's really gone down. It's hardly worth what? Anything, because in 10 years, the truck may not even start. Hopefully it will. But this is where, this is what we say, hey, this is a teenager truck. Because you guys can afford a truck that's 10 years old.
Our truck. I think our truck's 1 and 2.
Yeah, you can make them last. So at this point, you're probably worth just trying to keep it running because you want to pay anything.
But right now, it's 10 grand, so.
Oh, there you go. Yeah, it's worth more because they really don't depreciate. Again, does this rate stay constant?
No.
No, it depreciates quickly at first, but then it starts to level out and it won't depreciate at quite that quick of a rate. So it really won't probably go down this far. So that's true. But for this question, you want to say, hey, we have a constant rate. Even though, like I said, this 12% probably going to last for about 6-7 years, and then all of a sudden it's going to go off way less. It's going to be like half of that rate, probably going to go to 6%. That's what usually happens. Okay, so this is how you do all the questions 1 through, you can stop that now.